Dear learners, this is the concluding session on chapter Polymers. But before we start with this session, let me quickly run through what we had discussed in the previous sessions. We learnt about the importance and immense applications of polymers in our daily life. We also explored why some macromolecules are referred to as polymers and how polymers are classified into different categories. We also learnt that natural polymers are abound, but still there is a need to obtain semi-synthetic or synthetic polymers. We also familiarized ourselves with various terms such as monomers, homopolymers, copolymers and degree of polymerization. All these concepts are very well reiterated in this concluding session, wherein we will learn about natural polymer rubber, what is the need of vulcanization of natural rubber, what are the characteristic properties of synthetic rubber and their uses in various industries. We will also learn about relation between degree of polymerization and molecular mass of a polymer and a step towards conserving nature, synthesis of biodegradable polymers, and at the end we will also study about some commercially used polymers. Let us start with natural polymer. Rubber is a natural polymer and has varied use in household items and industrial products. The largest consumer is automobile industry, as it is used in the manufacture of tires and tubes. It is obtained from runny milky white liquid called latex that oozes out from the bark of rubber tree. These trees are mainly found in India, Sri Lanka, Indonesia, Malaysia and South America. Natural rubber is a linear polymer of isoprene. What is the IUPAC name of isoprene? I hope you all would be able to make out this. It is 2-methyl-1,3-butadiene, and therefore natural rubber is represented as shown in this picture, and it is also called as cis-1,4 polyisoprene. Let us study about a few of its characteristics. Natural rubber is a colloidal dispersion. I hope you all have read about what colloidal dispersions are in the chapter on solutions, but let us talk about it once again over here. It is also referred to as an elastomer. I am sure you all can recollect the properties of elastomers that we had studied in the first session. That is, various chains in the polymer are held together by weak van der Waals interactions. As a result, it has a coiled structure that can be stretched like a spring and thus exhibits elastic properties. Natural rubber becomes soft at temperature greater than 335 kelvins and brittle at temperature less than 283 kelvins. It has high water absorption capacity and is soluble in polar solvents. A very important property that needs to be highlighted is that it readily undergoes oxidation involving addition of oxygen group at a double bond, leading to the formation of new oxygen containing functional groups. This reaction changes the structure and properties of natural rubber. You must be wondering that can these properties be improved? The answer is yes, these can be improved by adding some cross-linking agent. A mixture of raw rubber with sulfur and an appropriate additive is heated in a temperature range between 373 kelvins to 415 kelvins. Sulfur forms cross links at the reactive sites of double bonds, and thus the rubber gets stiffened, and this process is referred to as vulcanization of rubber. During manufacture of tires, 5% of sulfur is used as cross-linking agent. The probable structures of vulcanized rubber molecules are depicted here. Because of varied uses of rubber in industry, synthetic rubber is also manufactured. The question is, what type of polymers behave like rubber? It is any vulcanizable rubber like polymer which is capable of getting stretched to twice its length. However, it returns to its original shape and size as soon as the external stretching force is released. Thus, synthetic rubbers are either homopolymers of 1,3-butadiene derivatives or copolymers of 1,3-butadiene or its derivatives with another unsaturated monomer. There are 3 synthetic rubbers that are used most commonly and about which we would be discussing in detail, and these are namely neoprene, Buna S and Buna N. Let us first learn about neoprene, which is also known as polychloroprene. It is formed by the polymerization of chloroprene. This is an example of addition polymerization through free radical mechanism, and I am sure you all remember that we have studied about free radical mechanism in detail in the previous session. Neoprene has superior resistance to vegetable and mineral oils and is therefore used for manufacturing conveyor belts, gaskets and hoses, while Buna S is an example of copolymer formed by addition polymerization of buta 1,3-diene and styrene in the presence of peroxide catalyst at 5 degree centigrade, and it is also called as cold rubber. This copolymer is quite tough and is a good substitute for natural rubber, and it is used for the manufacturing of auto tires, floor tiles, footwear components and cable insulation. Now, let us learn about what is Buna N. Buna N is obtained by the copolymerization of 1,3-butadiene and acrylonitrile in the presence of a peroxide catalyst. It is also called nitrile rubber, and it is resistant to the action of petrol, lubricating oil and organic solvents, and hence finds applications in making oil seals, tank lining, etc. So, these are 3 very important synthetic rubbers that are used very extensively in all industries. Now, let us learn about another characteristic feature of polymers. We all know that every molecule has a fixed molecular mass. This is how we identify or we recognize a molecule. But this statement cannot be generalized for polymers. While studying about the mechanism of polymerization in previous episode, we understood that the growth of the polymer chain during synthesis is dependent upon the availability of monomers in the reaction mixture and is a random process. The polymer sample contains chains of varying length and hence its molecular mass is always represented as an average. Depending upon the method of determination, there are 2 types of average molecular mass. One is number average molecular mass, the other is weight average molecular mass. It depends upon the technique that is deployed for the determination of molecular mass. The techniques that are dependent on the colligative properties will measure number average molecular mass. For example, the technique of osmometry or light scattering. When these methods are deployed, what we get is a number average molecular mass. Let us talk about another important aspect, that is sustainable growth, which is the concern of Mother Earth. So far, we have studied about various polymers, but a large number of these polymers are quite resistant to the environmental degradation processes and are thus responsible for the accumulation of polymeric solid waste materials and acute environmental problems. In view of the general awareness and concern for these problems created by the polymers, certain new biodegradable synthetic polymers have been designed and developed. These polymers contain functional groups similar to the functional groups present in biopolymers. The two important examples of this type are poly beta hydroxybutyrate co beta hydroxyvalerate, commonly known as PHBV. It is obtained by the copolymerization of 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. PHBV is used in specialty packaging, orthopedic devices and in controlled release of drugs. PHBV undergoes bacterial degradation in the environment. Another biodegradable polymer is nylon 2 nylon 6. It is a condensation polymer of glycine and aminocaproic acid. It is also known as alternating polyamide. It is used in the synthesis of artificial fibers, making strings of musical instruments and as threads in bristles of toothbrushes. Being heat resistant, these are also used as car components near engine. Though we have studied about various polymers with respect to their preparation and uses in these three sessions, a few commercial polymers along with their monomers and uses are listed in the table. These are namely polypropene, polystyrene, polyvinyl chloride, urea formaldehyde resin and glyptal. In polypropene, the monomeric unit is propene and this polymer is used in the manufacturing of ropes, toys, pipes and fibers, while styrene is the monomer of polystyrene, which is used as insulator, wrapping material and in the manufacturing of toys, radio and television cabinets. Polyvinyl chloride, that is used in the manufacturing of raincoats, handbags, vinyl flooring, water pipes has vinyl chloride as a monomeric unit. For making unbreakable cups and laminated sheets, urea formaldehyde resin is used. This is a copolymer of urea and formaldehyde. Glyptal is a copolymer of ethylene glycol and phthalic acid and is used in the manufacturing of paints and lacquers. Let us summarize what we have learnt so far. Natural rubber is manufactured from latex obtained from the bark of rubber tree. To improve upon its properties, it is subjected to the process of vulcanization. There are three important synthetic rubbers, namely neoprene, Buna S and Buna N. It has also been realized that because of enormous use of polymers, a lot of polymeric waste is generated and it is a environmental concern. Therefore, nowadays focus is on using biodegradable polymers such as nylon 2, nylon 6 and PHBV. Dear learners, based on these concepts that have been elaborated in this session, answer the following questions. Question number 1. A natural polymer X readily undergoes oxidation, thereby changes its properties. This characteristic feature of the polymer can be improved by adding a cross-linking agent Y. Identify X and Y. What is the source of natural polymer X? Question number 2. Comment on the statement, molecular mass of a polymer is an average molecular mass. Question number 3. How is nylon 6,6 different from nylon 2, nylon 6? Question number 4. Identify the following polymers from their uses. Also mention their respective monomers. Number 1. A polymer that is used in the making of television cabinets. Number 2. A polymer that is used in the manufacturing of paints and lacquers. Number 3. A polymer that is used in making raincoats. Point number 4. A polymer that is used for making laminated sheets. A polymer that is important in drug delivery, and the polymer which is used for making conveyor belts. Dear learners, I hope through these 3 sessions you have understood the basics and amazing concepts about the world of polymers. This is indeed a vast field, and in present scenario, it is among one of the frontier areas of research and innovation. You will get the opportunity to study in detail about this interesting field in higher classes. Till then, take care and happy learning.